Okay, today we're going to be working on some calculations. You will need a calculator to do this worksheet. So please, when you get a second, grab a calculator. We're still covering the gases unit. Today we'll be working on Charles' law and on Boyle's law. We'll start with Charles' law. Write down these formulas at the top. This one right here. And then write volume to temp. That's what Charles' law deals with, the two variables, volume and temperature. So for all of these problems, we want to organize our data. So we know what's given and what we don't have. So this ends in milliliters. We need to change it to liters. Let's move the decimal point 3 places to the left. Or if you want, you can divide by 1,000. So milliliters to liters, divide by 1,000. Just in case you forget, you will have to know how to do that on the exam. Okay, we're only using V's and T's. Is this going to be a V or a T? It ends in liters. Anyone? V. Okay, I don't know if it's V1 or V2 yet, but I'll do that at the end. 25 degrees Celsius. What unit does it have to be? It is going to be for our T. What can it be in Celsius? No, it needs to be in Kelvin. So how do we change Celsius to Kelvin? Add 273. So 25 plus 273. Okay, so this T equals 298 K. And it says it has a pressure of 736 mmHg. Okay, we need to change that to ATMs. We'll do a little math. Let me change this last Celsius because it's going to be easy. Just add 273. And if you know what we are doing through 1 through 5, you can go ahead and get ahead. 308. Oh. That's 308. Now I'm going to read the question in full so I can see which one was V1 and T1, V2 and T2. A container holds 50 milliliters of nitrogen at 25 degrees. What will its volume be if the temperature? So this is going to be my V1. This is what it started off with. There's my T1. And for this formula, we do not need to include this information. Okay? And this is my T2. The question is, what will its volume be? So for this one here, we do not know what V2 is. All I'm going to do is plug in my numbers. Okay? So for V1, T1, V2 I do not know, and T2. I'll give you a minute to write that down. We're solving for V2. Again, if you already know how to solve these problems, just continue to go ahead. This worksheet is due tomorrow. So to get V2 alone, I need to get rid of this. I multiply 308 on both sides. Now that's gone. This number says 308. So I'm going to do this divided by this. I'll get a number, and then I'll multiply it by that. That's what I'm going to type in my calculator right now. Go ahead and do the same. Okay, How about, what did you get, Ethan? Okay, and what did you get, Race? Mikkel? Okay. I'm going to type mine in my calculator one more time. I got 45,892. Okay, I made a calculator error. It's okay. I'm only human. I make mistakes. Yes, now that I retyped in my calculator, I did get 0.0516. Okay, and that's my volume, so it needs to end in liters. So there's not that much space. If you want to be more organized and do this on an extra sheet of paper, that's fine. Okay, I'm going to do number 2. A sample of oxygen occupies the volume of this at 91 degrees Celsius. Change this number not to 160 liters. Okay. What will be the volume of oxygen when the temperature drops to 0 degrees Celsius? What will be the volume? So again, for here, we do not have V2. Because it's asking, what will the volume be? So this is going to be my B1. That's what I started off with. And my T1, it started off at 91 degrees Celsius. B2, I do not have. T2, it's at 0 degrees Celsius, so 0 plus 273 will give me 273 Kelvin. I'll give you a minute to write that down. You can go ahead and plug everything in. Type it in your calculator and work it out. Dylan, what did you get? 120? Yes. V2 is 120 liters. Okay. This 212 centimeters, will you change that to liters, please? Okay, it says its initial temperature was 50 degrees Celsius. So initial, I'll organize my stuff over here. So T1 was 50. I need to add 273. Yes? Okay. And then the temperature is lowered to negative 5.0. Okay, when the temperature is lowered, it's my T2. What's your initial volume? So right away we know we're looking for V1. V2 is right here. I'm going to plug everything in. V1, we don't know. T1 is type it in the calculator. You can solve for that on your own. And you'll be responsible for 3, 4, and 5. If there's anywhere where it says centimeters cubed, go ahead and just change that to liters. Okay. And again, pressure does not matter for these. If you take a look at number 5, with the formula that we have, there's no P for pressure. So we're going to flip to Boyle's law. This will be a different formula. Something I want you to notice is when it's a formula like this, it looks like fractions. Okay, this is going to be a direct relationship. Just so when you're taking a look at your answers, or let's say maybe on an exam, you don't do any calculations and you're just going to take a guess. Given the numbers in the problem, you could probably guess your way through the exam if you know that if volume went up, temperature needs to go up, meaning it has to be higher than what's written in the problem. And for something like this, when formulas are written like this is an inverse relationship. So what that means is when pressure does something, volume's going to do the opposite. So it really just depends what the question is asking, but knowing those two pieces of information can help you make the best guess if you are confused or having trouble with the calculator. I'm going to stop it right here. We will continue this worksheet.